So today we're going to look at how to factor some special trinomials. Disregard the special functions there. This is from section 5.4 of the grade 10 text. The first kind of special trinomial that we're looking at is called a difference of squares. You'll get a question that says something like factor 4x squared minus y squared. If we can identify what item squared is 4x squared, like 2x, and what item squared is y squared, like y, then the factors are simply 2x plus y and 2x minus y. In 9x squared minus 16, that's the same as 3x all squared minus 4 all squared. So we get 3x plus 4 and 3x minus 4 as our factors. In something like x squared minus 1, that's the same as x all squared minus 1 all squared. So we get x plus 1 and x minus 1. Notice you get the square root of the first and the last. Square root plus the last, square root of the last, and square root minus the square root of the last. In example 4, we had to pull out the greatest common factor, but the rest is the same. 2 times x plus 5 and x minus 5. This one's a bit more involved. You'll notice it's a binomial squared minus a binomial squared. Still a difference of squares, just looks a little funky. But it works the same way. The square root of 3x plus 2 all squared is 3x plus 2. So I go 3x plus 2 in brackets plus x minus 3. And then again in square brackets, 3x plus 2 in brackets minus x minus 3. When we simplify that, we get 4x minus 1 and 2x plus 5. Notice on the right, the 2x plus 5 comes from 3x minus x and 2 minus negative 3, which is the same as 2 plus 3. X squared plus 25 is not factorable. The difference of squares would be x squared minus 25. We can factor that, but not the sum of squares. So x squared plus 25 or any sort of perfect squares added together can't factor. The next one here is x squared over 4 minus 9y to the 4th over 64. If we take the square roots of those to get our factors, we get x over 2 plus and minus 3y squared over 8. Same process. Now we're going to jump to our second special trinomial called a perfect square trinomial. And just to show how that comes about, we start with something like x plus 5 and we square it or rewrite it twice. When we expand, or when we use the shortcut that I showed you before, we get x squared plus 10x plus 25. Notice that there were two 5x's, two identical terms, so that they got doubled to make 10x. This is called a perfect square trinomial. When the first term is a perfect square, the last term is a perfect square, and the middle term is 2 times the product of their square roots, the first and the last. We'll show you that in this next example. So you're being asked to factor, if possible, something like x squared plus 6x plus 9. So note that in order for it to be a perfect square trinomial, the first term has to be a perfect square, which it is. X times x is x squared, so x squared is a perfect term, square. The last term is also a perfect square. 3 times 3 makes 9. The middle term should be twice as big as the product of the square roots of the first and the last. In other words, 2 times the square root of x squared times the square root of 3, or 9, which means 2 times x times 3, or 6x. So again, the middle term should be 2 times the product of the square roots of the first and last terms. 2 times the product of the square roots of the first and last terms. Square root of x squared is x, square root of 9 is 3, that makes 3x, times 2 is 6x. If that's the case, first and last are perfect squares, and the middle is, follows that rule, then the factors are square root of the first plus square root of the last. X plus 3 squared. It's x plus 3 because of the x squared plus 6x. Whatever the first sign is, that's the sign we get in our factors. For something like x squared plus 16x plus 64, same idea. we look at the first terms and the last terms. They're both perfect squares. Square root of x squared is x. Square root of 64 is 8. 8 times x is 8x. 2 times 8x is 16x. So that's perfect. 2 times the product of the square roots of the first and the last. So that means it is a perfect square trinomial. So my factors are, in fact, x plus 8 squared. Square the first, square the last, and the same sign as the first sign in the trinomial. I'm sure there's another one coming here. Let's say 81u squared plus 36u plus 4. Square root of the first is 9u. Square root of the last is 2. The first sign is a plus. And let's just check that our middle term works. 2 times 9u times 2 is 2 times 18u, which is 36u. Yep, absolutely. You'll notice all these perfect square trinomials, they all end with a positive term. That's important to note as well. It's impossible to have a perfect square trinomial where the perfect square at the end is negative. You can't multiply a number by itself and get negative 48 or negative 16. Okay? In this case, we pulled out the greatest common factor. B squared and 16 are perfect squares. Their square roots are b and 4. We check that b times 4 times 2 is 8b. Sure is. And there's our factors very quickly. 3 times b plus 4 squared.